All right, let's talk about the truncated cone. Um, Here's what we need to do. We've got this cone, it's got the top of it cut off, okay? So what we need to do is we need to imagine that we've reattached the top of this cone, okay? So then what we can do is we can find the volume of the entire cone, right? The volume of, we'll call it the large cone, right? The large cone. And then what we can do is we can subtract the volume of the small cone, okay? And that's going to end up giving us the volume of the truncated cone. Okay, so let's find each individual part and then we can define it, okay? So the volume of the large cone and the volume of the small cone are essentially going to use the same idea, okay? So anytime we do the volume of a cone, right? So let's start off by talking about the volume of the large cone, okay? This is going to be the area of the base multiplied the height divided by 3, right? So the volume of the large cone is going to be, I have the area of the base is a circle, so it's going to be pi times the radius. Well, the radius is 10 squared and then h, but I don't know the height of this cone, okay? Because the height of this cone, we'll call this A, right? We can call this B, okay? And I don't know from A to B, all right? I also don't know this thing, right? But the height of the small cone, right? Because if I do, let's see, the volume of the small cone, where do I want to put this? Let's put this here. The volume of the small cone is going to be the same thing. Area of the base multiplied by the height divided by 3. Okay, well that's going to be equal to pi times the radius squared, which is going to be 4 squared, multiplied by, and I don't know the height of that one either, right? That's this distance, right? And we'll call this one, well, let's call this, we'll put this point here C, and we'll call this D, and we can call this point here E, okay? So what I need to do here is I need to find from B to D, right? That's the height of this small cone. Well, I don't know what that is, so maybe we can call it X, okay? So in order to figure out this, okay, I'm going to use this idea of similar triangles, okay? So let's go ahead and I'm going to do this in red, and so we'll do this triangle here, okay? A, B, C. And what I'm going to do is hopefully I can grab it. Uh-oh, that's not what I want. Let's try that again. Let's undo this. So I'm going to pull this one. No, that's still not the right way. So let's go ahead and we'll do this. Okay, and now I think I can pull it out. Okay, so of course now it pulls C with it also. Okay, now there we go. Okay, so I have this large triangle, right? So the large triangle, okay, and this one is called BAC, right, or ABC. And I know that this is 10. I don't know C to B, and I know AB is going to be this one, right? It's X plus 8. So this is X plus 8. All right, well then let's go ahead and let's look at the smaller triangle here, this one. So I've got this down here and then over to here, okay? And then what I'm going to do is I'm going to go grab this one. Come on. Oh goodness, it's too small. Can't grab it. Nope. Hold on. Let's see if that works. Yes. Okay. So now I've got that triangle, and that's a terrible, it's not even close to straight, right? But we're going to work with it. Doesn't actually matter as long as we're using the right ideas. Okay, so I know that triangle BDE, all right, this triangle, the green triangle, is similar to this triangle, okay? So what I'm going to do now is I am going to create a ratio, okay? So I'm going to create a ratio of, right, this means all of these sides compared to all of these sides must follow the same number, right? It's a dilation. It's a dilation meaning K, right? So 4 to get to 10, right, from 4 to 10 is actually 2.5, which means that from X to X plus 8 is going to be 2.5. But I can write that ratio, okay? And what I'm going to do is I'm going to compare sides. So what I'm going to do is I'm going to say, okay, this side, AC, right? Triangle or a side AC, side length AC of this triangle, okay, compares to what side length of this one? It compares to DE, right? And it's important that I keep the order the same. And that's going to be equal to, okay, well, from AB, that's going to be compared to DB, right? DB. Well, now what I'm going to do is I'm going to go ahead and I'm going to fill in these values. Well, I know that AC is 10, right? And DE is 4. And I know that AB is x plus 8. And I know that DB is x. And now what I'm going to do is I'm going to cross multiply in order to get my answer here, okay, to figure out what x is. So I'm going to cross multiply. So I'm going to take 10x is equal to 4 times x plus 8. Then I'm going to distribute. So I get 10x is equal to 4x plus 32. Then I'm going to subtract 4x from both sides, and I get 6x is equal to 32. I'm going to get divide by 6, so I get x is equal to 32 over 6. I'm going to simplify that. Both of these are divisible by 2, so I get 16 over 3. Okay, so I have 16 thirds. So then let's go ahead and I'm going to say pi times 10 squared. Okay, so now I know that x, right? X is this one. This is the large cone, right? So a large cone is going to be 8 plus 6x, right? So let's do that. Let's figure out what is x plus 8. So x plus 8, right? So the height of, and I'm going to call this height 1, and we can call this height 2, okay? Right, so we'll say that height 1 is equal to x plus 8. So height 1 is going to be equal to, this is going to get to, let's do this. Let's see if I can get in here real quick. Hold on. Sorry, technical difficulties. Where is it? I'm looking for, there it is, page extender. Okay, so we're going to use this for a minute. All right, so now I'm just going to kind of go down a little bit. All right, so I know that we knew that height 1 was equal to x plus 8, right? And height 2 was equal to x. So height 1 is going to be equal to x is 16 thirds plus 8, okay? Well, I want all of these to be the same size. So height 1 is going to be 16 thirds, and I'm going to turn 8 into thirds, right? So if this is 8 ones, so if I turn it to thirds, it's 24 thirds. So the height of the height of the entire thing is going to be 40 thirds, okay? And then I know that height 2, right, the height of the small cone is going to be equal to 16 thirds. Okay, so let's use these ideas. Okay, let me go on back up. How do I go back up here? I think I got to grab it. There we go. All right, so now let's come back here. And so now I know that the height 1, right, is 40 over 3, right? And then this whole thing gets divided by 3. So let's do this, okay? Let's combine it. 10 squared is 100, okay? 100 times 40 is 4,000 pi all over, 4,000. So ignore the bottom here, okay? So we're only working on the top here, okay? Just the top. 4,000, right? So it's going to be 100 times 40 is 4,000 times pi, so 4,000 pi, and then we're going to divide by 3. Okay, that's the volume of, right? That's this part. So now what we're going to do is then I have to take whatever that is and divide it by 3. Okay, hopefully you're okay with that. Then same idea with the small cone, right? So I know that the height here is 16 thirds, and then I'm going to take all that and divide by 3. So let's do this. 16 squared is 16. Oh, sorry, 4 squared is 16. 16 times 16 is 256. 256 times pi. Okay, so I'm going to get 256 pi over 3, and then this is all over 3. Okay? Good, good, good. So here's the volume of the large cone, and this is the volume of the small cone. Now what I'm going to do is we're going to go ahead and we're going to, move this down a little bit, okay? So now let's combine, right? So now what I got to do is I'm going to have to subtract these two things. So I'm going to take the volume of the large cone, right? Remember we had volume of large cone minus volume of small cone is equal to volume of the truncated cone. So the volume of the large cone is this. So it's 4,000 pi over 3. Then I'm going to divide that by 3. Okay, and then I'm going to subtract 256 pi over 3 all over 3. Okay. Well, now notice these denominators are the same thing, right? So what I can do is I can take the numerator of this and subtract the numerator of this. Okay? So okay, so now let's look at this, and we've got 4,000 pi over 3 minus 256 pi over 3. So from here, let's go ahead. Since these are also the same pieces, okay, and these are both talking about pi, I can say, okay, if I have 4,000 pi and I take away 256 pi, then that's going to leave me with 3,744 pi. And these are both of the denominator 3. And then when I'm done with that, I'm going to divide the whole thing by 3. Okay? Well, now let's look at 3,744. Well, if I add up all these digits, 3 plus 7 is 10, plus 4 is 14, plus 4 is 18. 18 is divisible by 3. Okay, so let's go ahead and we'll divide 3,744 pi, and we'll divide it by 3. Okay, I'm going to move this page down a little bit. Okay, so now let's do, okay, 3 goes into 37. That goes in 12 times. Okay, with 1 left over, that gives me a 140. In fact, let's just do this. 3,744, right? Divided by 3. 3 goes into 3 once, 3, 0. 0 left over, okay? 3 goes into 7 2 times. That uses up 6, okay? I have, whoops, yeah, I've got 1 left over. Okay, so you subtract that, I get 1 left over. Okay, so then I bring the 4 down. 3 goes into 4. How many times? It goes in 3 times. Okay, so then, no, 3 goes into 14 4 times. Okay, 3 goes into 14 4 times. Okay, so then I use up 12, subtract what I have left, 2. I'm going to drop the 4 down, makes it 24. So 3 goes in that 8 times. Okay, so now I've got 1,248 pi, right? And now this thing here has been simplified to this. So now I got to take that and divide by 3. Okay. So now let's do this. 3 goes into 12, right? That goes in 4 times. And then how many times does 3 go into 48? It goes in 16. So now it's 416 pi. Okay. Oops. I forgot something. My units, which were, I believe, inches. Okay, so now it's going to be inches cubed. All right, so that's the worked out way that we did this one in class. I know it's crazy, but if you can get this problem, you are well on your way to being very successful with these types of things. Okay, this is using the similar triangles to determine the missing height of a truncated cone. It's good. It uses a lot of the stuff that we've learned this year. So hopefully this helps. Use this, okay? Ideas to help you finding the other truncated cones, and I hope it helped.